Hey everybody, it's Mr. Grosso back again. What I want to do before we get going on today's stuff is just go back and review one thing real quick. You guys know how I love reviewing things real quick. Alright, so why is it important to simplify fractions when we can, when it's possible? So if you remember, I gave you guys a situation like this a while back. If you don't remember, there's nothing like hearing it again. If you do, it'll be real quick. So taking a look at this fraction right here. Right? How easy is this to be able to wrap your head around it, be able to use it, talk about it, apply it? It's really kind of crazy. Some of you guys might be able to do it. Some of you guys might have this make total sense to you. But a majority of the people, probably not. Right? If you took this and you simplified it, look how much easier it is. Everybody can understand this, use it, and apply it way easier. And that is why it is important to simplify these things. All right, it's just easier understood, apply it, talk about it, all that good stuff. So what we're going to be doing today is adding and subtracting fractions. But in order to do that, you need one thing. Simplifying may be something that we do later with some of these, but not all of them. But no matter what, if you're going to add or subtract fractions, you need common denominators. So all the problems that we're going to be talking about today have common denominators, making it easy to start. All right, again, you know how much I like making things easier to start. So what we're going to be doing is adding and subtracting with proper fractions with common denominators, and then we're going to do some that are going to be mixed fractions. But as you can see from here, part one, I'm going to break this video into two parts. So if you want to listen to just certain parts, it'll be easier to just go to a different video, so you don't have to find the spots and all that stuff. Try and make it easy for you guys. So part one, adding and subtracting proper fractions, all right, with common denominators. So remember what the denominator represents? That represents the whole, all right, how many it takes to have a whole of whatever you're talking about. And the top numbers represent what you actually have and are working with. So this 15 and this 7, that's what you're doing. That's what you're working with. The 21 is just like a representation number. All right, that's, again, how many it takes to make a whole. So 15 and 7, this guy right here is your subtraction. So you got a positive 15, negative 7, or minus 7. So 15 minus 7 is going to give you 8. And the 21 stays exactly the same. So in order to put this in terms of like an example, like apples, easy. So if there's a total of like 21 apples, all right, we're starting off with 15. All right, Meatball comes over and takes 7 for, I don't know. He's going to have a few, he's going to throw a few, he's going to throw some in the trash. I don't know, whatever. Whatever Meatball decides to do with these apples. So 15 minus those 7 that Meatball took, we got 8 left over. All right, out of the total of 21 that it would take to make a whole group of whatever we got. So that's what we're doing. That's what we're looking at these fractions with. All right, if you're looking at this one, again, 9 is the number that it takes to make a whole, but these are the ones that we're doing the work with, the numerators. So 8 plus 5 this time is going to give you 13 over 9. So this is the improper situation that we are talking about, where simplifying is going to come into place. Improper fractions are not bad, but mixed is always the nicer way to view this stuff. People like whole numbers when we can deal with them. All right, so how many 9s can you get out of 13? This is exactly the stuff that we were doing yesterday. So you're only going to be able to get 1 out of it. How many is that left over? That's going to be 4 left over. And then you still got the numerator of 9. All right, and then there's going to be situations like we've been dealing with the integers and with the decimals. Now we're dealing with it with the fractions. All right, you have 3, but you're taking away 8. So remember, if you guys are in a situation like this where you're taking away more than what you have, just flip it. Start with the 8 and subtract the 3. Start with the larger number and subtract the smaller number. It doesn't matter how you subtract two numbers. The distance between those two numbers, or the difference between those two numbers, it's the same thing, is going to be the same distance or the same difference. The only thing that's going to matter in those situations is what sign the answer gets. All right, so remember this stuff over here. So 8 minus 3 is going to be 5. This guy is a positive 3, and this one is a negative 8. So which one is there more of? The negative 8. So it's going to be a negative 5 over 14. So remember, if your answer is negative, just throw that little negative sign in there. All right, if you hit the space bar, it's going to consider it kind of like one of those indentation things. So just type the negative type the negative sign and then the number, and you're good. All right, just a couple more examples in this first part, and then I'm going to stop it and record for the other video. All right, so again, you got a negative 13 over here, but a positive 4. These guys are opposites, so you got to subtract. 13 minus 4 is going to give you a 9, but what kind of 9? Which one is there more of? Negatives. All right, and then you still got the 14 on the bottom. All right, this one right here, again, remembering these rules, the integer rules. You guys love that song. Maybe we'll listen to it when I come back. You got negative 25 and you got negative 19. So since they are both negatives, you are adding them to be a larger negative. So that's going to give you negative 44 over here. But it's still going to be out of 36. So even if it's an improper situation like this, it doesn't matter if this is a negative number or a positive number, you can still make it into a mixed. So how many 36s can you get out of 44? Only one. But since this is a negative, the negative now stays on the outside here with the whole number. And then these guys just can be numbers without the signs, because you got the sign right here on this one. So how many do you have left over after you pulled the 36 out of 44? You got 8 left over out of that 36. And again, this is where that simplifying comes into play. We can simplify the fraction part. Whole number is going to stay the same, but the fraction part you can make smaller. So you can divide both of those by 4. All right, how many 4s can you get out of 8? 2. How many 4s can you get out of 36? 9. So that's the best possible answer you could have. All right, this one's good and this one's good. They're all saying the same thing. This is good, this one's better, and this is the best, nicest answer you could possibly get. All right, so let's jump down here to this one. Whenever you guys see this sign right here, I'm trying to let you know that it's going to be a rewrite problem. So you have those two signs right next to each other. All right, what do those signs get replaced with? Plus sign. All right, all these numbers stay the same. All right, the sign just drops off of that 13 because those two come together to make that sign. All the other ones stay the same. The only one that it affects really is that 13 right there. So now this is what that problem gets represented by now that we've simplified and cleaned it up a little bit. So 11 plus 13 is going to give you 26, and it's still out of that 17. How many 17s can you pull out of 26? Just one. All right, and then how much are you going to have left over? 9, and then out of the 17 right there. All right, so this was just the part 1. All right, if you guys want to listen to the part 2, go click on that video. I'll meet you guys over there. Peace.